Welcome back. This is another episode of solving of questions on the quadratic equation. This question is a past question, and it says that write the equation x squared minus 7x plus 6 in the form x minus a all into bracket plus a squared plus b. State the coordinates of the minimum point on the graph of y equal x squared minus 7x plus 6. The third one, find the coordinates of the points where the graph of y equal x squared minus 7x plus 6 crosses the axis, and sketch the graph. Show that the graphs of y equal x squared minus 7x plus 6 and the second graph y equal x squared minus 3x plus 4 intersect only once. Find the coordinates of the point of intersection. I'll read it again. Write x squared minus 7x plus 6 in the form. The first one, x minus a all into bracket raised to the power 2 plus b. State the coordinates of the minimum point on the graph whose equation is y equals to x squared minus 7x plus 6. The third one, find the coordinates of the points where the graph of y equals x squared minus 7x plus 6 crosses the axis, and sketch the graph. And the fourth part, show that the two graphs of y equal x squared minus 7x plus 6 and y equal x squared minus 3x plus 4 intersect only once. Find the coordinates of the point of intersection. Take your time to copy this one, and then we'll pick it up from there in the solution thereof. Okay, welcome back. As we are studying the first question, the first part of the question. Yeah. Good. The first part says that write down this one in the form of x squared, s plus s minus a, all raised to the power square plus b. Solution. Let this equation, let it be equal to y equal x squared minus 7x plus 6. And then this portion will complete the square. So it becomes y equal x minus 7 over 2 square minus 7 over 2. That's minus 7 over 2, the same here. Square, then plus 6. Very good. Then it follows that y equal x minus 7 over 2 square. Then you have minus this portion becomes 49 over 4 plus 6. Then you have y equal x minus 7 over 2 square minus 6 plus this one. Plus 6. We are interchanging the positions. Minus 49 over 4. If we continue from here, we will have y equal x minus 7 over 2 square. 6 times 4 is plus 24 minus 49 over 4. Y equal x minus 7 over 2 square minus this one minus 25 over 4. So you can see that this one is identical to y equal x minus a square plus b, which indicates that a is equal to 7 over 2 and b is equal to minus 25 over 4. Very good. Take your time to copy from here up to here, and then I will pick it up from here at this point while I will wipe off the board at this point. Take your time. Now, we see that x squared minus 7x plus 6 was equal to x minus 7 over 2 x squared minus 25 over 4. It was very much identical to, how was the question? It was very much identical to x minus a square plus b, where the b is equal to negative 25 over 4. And the a is 7 over 2. This is the equation. I'll call it equation sigma. This portion is the symmetrical term. And this portion is the y minimum term. Therefore, at some point you heard that the question says that, I think, find the coordinates of the minimum point. Okay. To find the coordinates of the minimum point, you pick out the symmetrical term. Because the symmetrical term is a square quantity, it can never be less than 0. Therefore, as we've been always repeating, the symmetrical term the symmetrical term being a square quantity can never be negative. Therefore, x minus 7 over 2 square, if it can never be negative, then it is greater or equal to 0. Which implies is x equal 7 over 2. This value is the x value where the symmetry occurs. Where the symmetry occurs, the symmetry is the line that divides the graph, the quadratic graph, into two equal portions. It occurs as 7 over 2. And then the y minimum term is minus 25 over 4, which implies is where the symmetry occurs, y is equals to y minimum, which is minus 25 over 4. Therefore, the coordinates of the minimum point of the graph of this equation is equal x equals 7 over 2. Yeah, you can see it. And y equal minus 25 over 4. These are the coordinates of the minimum point, meaning, in other words, we say that These are the coordinates of the turning point. It is the same as the coordinates of the minimum point. Then that part of the question is being dealt with. Very good. Take your time to copy everything. As I stand here to make a space for you that you can see clearly on the board, take your time to copy everything. And then we'll pick it up from there. From the next, we'll continue the next portion being the third portion. Thank you. Welcome back. To continue the next part of the question, that says that find the coordinates of the point where the graph whose equation is y equal to x squared minus 7x plus 6 crosses the x-axis and sketch the graph. As I said, that's the third portion. State the coordinates where the graph will pass through the axis. In this case, we shouldn't forget that this equation, we will use this same equation. This equation is equal y. This is the equation of the curve. So you can see that on the y-axis, x equals 0. When the curve crosses the y-axis, or the curve crosses the y-axis where x is equal to 0, in that case, if you pick up this equation and put s equal to 0 in this equation, you can find that y is equal, if this is 0 squared minus 7 times 0 plus 6, we have y equals to 6. So this is the y-axis intercept. Secondly, I'll call this one A. Secondly, on the x-axis, y will be equal to 0, which implies this equation becomes 0 equal s squared minus 7x plus 6. Very much identical to x minus 7 over 2 square minus 25 over 4. Okay, if the left-hand side is equals to 0, then we can find that 0 is equal to x minus 7 over 2 square minus 25 over 4. Good. In which case, is there any place that we can borrow? We can. So, we continue from here. You can find out that this portion becomes x minus 7 over 2 square will be equal to 25 over 4, which is no different from x minus 7 over 2. We will take square root on both sides. So we have root of 25 over 4. Is there a space there? Yes, there's a space there. So you can see that x minus 7 over 2 equal 5 over 2. Good. Take your time to copy, and then we'll pick it up from here again. Take your time to copy. Now, continue from there. We find out that x minus 7 over 2 equal 5 over 2. which implies is s equal 5 over 2 plus 7 over 2, which is not different from 12 over 2 equal to 6. Oh, sorry. This portion, because we took square root on both sides, this will be equal to plus or minus. So this is plus or minus. So x1 will be equal to 6 and s2 equal minus 5 over 2 plus 7 over 2, which equal 2 over 2, which implies is s2 equal 1. Therefore x1 equals 6 and x2 equal 1. You couldn't see it. So therefore, I'll continue from the other side. So we find it out that x1 equals 6, while x2 equal 1, which implies this curve will pass at where s equal to 6 and x equals to 1. S1 equals to 6 and S2 equals to 1. These are the x-axis intercept. But remember, the y-axis intercept was y equal 6. So x1 and x2 are the x-axis intercept, and y equals to 6 is the y-axis intercept. You can see that the next part of the question, we are requested to sketch the curve. Take your time to copy this one, and then we will try to sketch the curve. Now, see that in trying to sketch the curve, it will look like something like this. And this is the y-axis. And this is the x-axis. So, we have the values of intercept to be x. Previously, it was x equal to 1 and s equal to 6. Let me check it. We'll check it. So, assuming this is can you see the board? Maybe I should lift it up a bit so that you can clearly see the board. Okay. this is the, previously we found that the y-axis intercept was y equal to 6. This is y. And the x-axis intercept was x1 equal 1. And then this one, S2 equal 6. And the symmetry occurs at 7/2, which is about 3.5. This is where the symmetry occurs. The symmetry divides the graph into two equal parts. So this is the symmetry. Here, S is equal to 7/2. And then y minimum is equal to minus 25/4 minus y minimum equal minus 25/4. This is the y minimum. So you can see that the coordinate of the turning point, this is the turning point, will be S equals to 7/2 and y equal minus 25/4. There is something that I want to stress out, because if you see here, since the y minimum value is negative, it tells you that in fact the graph will cross the x-axis. In most cases where the y minimum term or y maximum term is positive, it tells you that when it is positive, it tells you that the graph will not cross the x-axis. It will only cross the x-axis when the y minimum term is negative. Now, it indicates that this portion of the question is also being dealt with. Then, our next question will be the question 4. That says that there are two graphs where one is equals to this one, s squared minus 7s plus 8. And there's also another graph has been introduced whose equation is y equals to s squared minus 3s plus 4. And the question says that show that these two graphs intersect only once and find the coordinates of the points of intersection. This is good. Now, take your time, because you copied the earlier question. Take your time. Finish this question, finish this part, while we will tackle the last portion of the question. Take your time. Now, these are the two curves. The first one was y equals s squared minus 7x plus 6 is the first curve. And the second curve says that it is, let's find something to work with. And the second one says that y equal s squared minus 3x plus 4. We are to show that these two curves, they do intersect but once. How do we do that? Two curves, or a curve and a line, or a line and a line, different line, different line, or different curve and another different curve. For instance, like this one, these two curves, they intersect if and only if their y values at the point of intersection are the same. Under that condition, probably, let me write it here. these two curves will intersect if and only if their y values are the same at the point where they do intersect. Good. What's the meaning of that? At the point of intersection, y will be equal to y. This equation will be very vital. I'll call it equation 5. Good. The two curves will intersect when their y values are the same, in which case, follow from equation 5 or from the logics of equation 5, we can see that x squared minus 7x plus 6 is equal to x squared minus 3x plus 4, in which case this x will cancel this x. Then we will be left out with minus 7x plus 6 equal minus 3 minus 3x plus 4, which implies is we are bringing this expression at the right hand side, we are bringing them to the left hand side. So we have minus 7x plus 6. It is minus here. Once it crosses the equal sign and comes to the left hand side, it becomes positive. So we have 3x. This is positive over there. Once it crosses here, it becomes negative. So we have minus 4. Then we are left up with 0. So collecting the like terms together, we have minus 7x plus 3x plus 6 minus 4 equals 0, which implies as minus 7x plus 3x will give us minus 4x. 6 minus 2 will be equal to 2, which is also not different from 4x equal 2. X equal 2. You cannot see it. So where could you see? Yeah, you couldn't see it. Because if I look on my, I have a screen here. If I look on it, if I can see it on the screen, you can see that. So you could only see up to this point. Let's continue from there. So we have minus 4x plus 2 is not different from 4x equal 2, which implies x equal 2 over 4, which implies is s equal half. Good. So we can see that the two curves will intersect at where x value is equal to half. Now, can we also find the y values? Oh yes, it is possible. To find the y value, we can either use this equation or this equation. It doesn't matter which one we take. So preferably, as a choice, let's try to take the first part. So the first part says that y equal s squared, but we know s squared is equal to half square minus 7 times half plus 6. We have y equal 1 over 4 minus 7 over 2 plus 6. If you cross multiply, or you solve this one first, so you can have y equal, because of the board, let me see how we'll come up with. We should have y equal to 11 over 4. Yeah. You can also use the x value as some homework. You can try by using the x value of s equals to half. For this equation, you will still come up with y equal 11 over 4, which indicate that the two curves will intersect at this point. These are the points of intersection. Yeah, where s equals to half and s equals to, and y equal to 11 over 4. S equal to half, y equal to 11 over 4. It's the point of intersection of the two curves. Now, we can still sketch that curve, because, as far as the question is concerned, the question says that find the s-coordinate of the point of intersection. So by the time we found this one, we were done with the question. But based on the free gesture, we extended ourselves to find the y value, which is not bad. So we can say that the proper coordinates with including y is coordinates of intersection is s equals to half, y equals to 11 over 4. Though this part of the question was not asked, but based on the free gesture, we extended ourselves and we came to this point. Now, based on another free gesture, because this is a private tuition, I see no reason why you shouldn't be giving the best. And for this reason, I think we will try to sketch the second part of the curve. Let's see it. Already, previously, we sketched this one. And at this time, we are going to sketch this one. And we will see how the two curves intersect. So at this time, I would like you to take your time to copy everything from the whole session, and then we will take it from there. Now, let's continue with this graph. Y equal s squared minus 3x plus 4. We will complete the square. So can y equal x minus 3 over 2 square minus 3 over 2 square. This portion is this portion. We have completed the square, and then we have plus 4. So you have y equal x minus 3 over 2 square minus 9/4. Plus 4. If we continue, we have y equal x minus 3/2 square plus 4 minus 9/2, which is not different from x minus 3/2 square plus 8 minus 9. Cross multiply, let's say, over 2. So we have y equal x minus 3/2 square minus 1/2. This is the symmetrical term, and this is the y minimum. This curve also, because the y minimum term, which is minus half, because it is minus, it indicates that this curve also will cross the x-axis. And the y minimum term is, let me say, this is the symmetrical term. Symmetrical term. Yeah. Symmetrical term. And this is the y minimum term. It tells you that the symmetry occurs at 3/2, and the y minimum is half. So, for that graph, it will look like y x. It will look like, if you look to this equation, you can see that there, I think we still have to, we still have to consider one or two things before we sketch the graph. So, look at this equation. This equation is the same as, I think, take your time, copy this one, and I'll pick it from there, and then we'll continue. Take your time. I'll pick it from here. I just want to do systematic work without rushing. Yeah. Good. We are picking up from the last session. Very good. Intercept on the y-axis, x equal to 0. So if x equal to 0, then intercept on y-axis, when x equals to 0, then we'll have y equal 4. We say intercept on the y-axis. Okay, similarly, intercept. Similarly, on the x-axis, or intercept on the x-axis, y will be equal to 0. Therefore, on the x-axis intercept y equals 0 in this equation. So it becomes 0 equal x minus 3/2 square minus half, in which case we will have X minus 3 over 2 square will be equal to half. If we continue on the other side, we can see that x minus 3 over 2, taking square roots on both sides, will have plus or minus 1 over root 2 half, which indicates that x1 equal plus 3 over 2 plus 1 over root 2. Good. And x2 equal 3 over 2 minus 1 over root 2. These are the x-axis intersects. So you can see that for this curve, on the y-axis, the curve will cross the y-axis at where y equals to 4, and it will cross the x-axis at where the x equals to 3 over 2 plus 1 over root 2, and s2 equals to 3 over 2 minus 1 over root 2. Now, based upon this one, let's try to sketch the curve. We can see that, take your time, copy everything, and then we'll pick up from here. Take your time. Now, this should be the curve. This is the y-axis, and this is the x-axis. On y-axis intercept is 4, and the x-axis intercepts are these. So you can see that this one will be like this, where this one is 4, this is the origin though, and this is the minimum value of x should be this one. This is x2. And this is the maximum value of x. It should be this one. This is x1. What is x1? x1, you can see that it is 3 over 2 plus 1 over root 2. And what is s2? s2 is 3 over 2 minus 1 over root 2. Good. So, previously, we found that the y minimum was which is this one, is minus half. Y minimum, which is this one, is minus half. That's the y minimum. Very good. Now, this is the equation y squared. This graph is y equal to s squared minus 3x plus 4. Now, we are going to blend the two curves that we had previously. Take your time, copy this one, and then we will draw the two curves on the same axis. We'll draw it at the right hand side, at that side, at this side. Okay, take your time. Yeah. This was, let's say, this is the graph. Previously, we found out that the first graph was like this. Very good. And the equation, sorry. y equal x squared minus 7x plus 6. This is the origin. And the second one was the first one, we found out that it was, let me find how, because I did everything. Y minimum was, because I don't have, Y minimum was, what was Y minimum? Y minimum was 25 over 4. That was Y minimum minus 25 over 4. Very good. And this one, y-axis intercept was 6. Okay. And we have the symmetry. We said that the symmetry at that time was here, which was 7 over 2. Very good. And x was 6, this was 6, and this was 1. Very good. And this second equation, the graph will be y-axis intercept is 4. Possibly something here. And then it crosses the x-axis. I don't have it here, but I mean, you can check it on your notes. So it will be like, at least we know that the y minimum for this equation, let's see, the y minimum we found out that the y minimum is half. Y minimum. And this one was y minimum. Yeah. So here, let's say here. And the symmetry was, I think it was 1.5, so that it has different symmetry. So you can see that. This one is 4, as we can see, and the y minimum is the y minimum should be something like, this is just a rough sketch, just to give you an idea of everything that we are. Very good. And at that time, oh no, it shouldn't be, because No. Shouldn't be. Should be something like this. No. Because we are not drawing it on scale, should be the previous one. This was 1 and this is 6. That equation is y equal x squared minus 7x plus 6. And this place is 6. And this is the y-axis. And this is the x-axis. And this is the origin. And the second part of the second graph, it will be something like very good. This one was the x-axis intercept of the first one was 3 over 2 plus 1 over root 2. And this one is 3 over 2 minus 1 over root 2. This one. Very good. And this is the coordinate of the point of intersection that we found previously. Here is 4. And this was the coordinate of the point of intersection of the two graphs. So previously we found out that that coordinate of the point of intersection, this point, the coordinate was half is equal to half and y equal to 11 over 4. Very good. That was the coordinate. So if we are trying to draw it properly, we can find it out that the graph and then the other one will be this point of intersection is what we call half and 11 over 4. And this is 4 and this is 6. Yeah. And this point here, this point was s equal to 1, and this point was s equal to 6, and this point of intersection is the 3 over 2 plus root 2, and this point of intersection is the 3 over 2 minus half, and this is y minimum equal minus half minus half and this y minimum is minus 25 over 4. You couldn't see it. Y minimum minus 25 over 4. Very good. And this equation, this is the graph of y equal s squared minus 7x plus 6. And this is the graph of y equal s squared minus 3x plus 4. This is the y-axis, and this is the x-axis, and here is the origin. Yeah, then successfully we have done with the question. It was an interesting one, though it was a short question, but because of extensive explanation, that is why it has taken us such a long time. And it deserves that we take our time to explain everything without rushing. So at least, this one being a private tuition, I see no reason why that, we have to rush into things. This makes it different from the mainstream tutorial that we have it in schools. This is a private one, and you deserve the best. Yeah, then thank God that this time we have brought this session to a close. And let me pray for you. The Lord Almighty God bless you. The Lord Almighty God keep you. Lift up his countenance upon you. Make his face shine upon you and give you peace. Shalom, shalom, shalom. God bless you. Ephraim. Now, take your time. I think you are taking your time to copy everything. It is very interesting that, we have come to such a celebrating conclusion. I'm very much pleased with everything that we've done. We have stressed ourselves, going to such analytical detail, which is very, very, successful. It is not everywhere that you can have the opportunity where simple things like this can be explained into every minute detail. But I think that since this is private tuition, you deserve the best, and the best should be given to you. And I pray that not only for the GC, not only for the A-level exams, honestly, as a producer, someone who studied engineering and advanced mathematics, I know that this application thereof, you will use them extensively in many areas of mathematics in your future practicing being an economist or being an engineer, a mechanical engineer, civil engineer, aerospace engineer. I mean, they play such a major role. And things like, even in electrical engineering, there are some areas, you apply such an extensive knowledge. This is it. Now, I will say it again by saying that the Lord Almighty God continue to be with you and give you restful time and peace. God bless you. Bye.